Welcome to Telco Bridge's ProSBC TechTrain Module 215, covering the internal architecture of ProSBC, learning how the 1+1 redundancy is accomplished, and protecting from DDoS attacks. This provides a deeper understanding that comes in handy when designing complex systems. So let's join Luke to learn more.
So next step is the SBC detail. So we go back down deeper in the system to better understand how it works. So internal architecture of the SBC, type of protections that are available, access control, and what can we get in this SBC status. So we saw that yesterday. That's the questions we got yesterday. So the management interface, and actually I should here add, well, it's here, control, right? Control 0, control 1 will also go through this path here. So regular kernel and CentOS kernel path. And the reason is there's not a lot of information sent usually on the management interface and also on the control interface. It's just setting up a few channels, stuff like that. So the traffic is very low. And also, normally these are, at least the control network usually is a private network, right? Management network, then either it's a private network or either you protect it with a firewall if you want to be accessible from outside. But every other LAN 1 traffic will be protected by the SBC, the rules of the SBC. So only what is accepted will be sent to the SBC applications. For example, SIP calls on pre-configured network access points. So if you configure the network access points, then you'll be able to receive the SIP calls. If it's not configured, you don't know this IP, for sure it's not going to pass. And in addition to this, the RTP traffic is handled by the module called TBrouter, and the SRTP, either SRTP relay or SRTP decryption encryption will be done in the TBrouter. That's maybe something I didn't mention yesterday. If you have an incoming NAP with SRTP and an outgoing NAP with SRTP, we don't need to decode and re-encode the SRTP. It's going to be automatically forwarded to the other leg, and it's not going to be processed here. Okay? If it's for one leg is RTP, the other leg is SRTP, then it will encode it and decode it. Okay? Okay, then if we have transcoding, so what happens is we receive the SIP call. In the SIP call, we try to match the codec so that there's no transcoding, but it happens, we need to do transcoding, and we have a transcoding unit available. What TBrouter will do is take this RTP traffic, send it out to the, these are the trans 0 and trans 1 networks. It's just LAN 1 interface used for accessing the transcoding unit, and the transcoded information will be received back and sent out. Right? So the only thing you have to do, viewed from the installation point of view, is make sure these interfaces are available. Then you put this system in your rack, and you add in your configuration saying, yes, I have a transcoding unit, and that's the serial number of this unit. Okay. So we looked at some of these applications already, but here I'm trying to just display just a bit more how it's being what are the connections between these applications, what are the paths that are being done in the system. Okay. So in general, we have the management interface, which is connected to Well, here I put web portal, but it's also SSH, SFTP, so basic access to the system. And when you change configuration in the web portal, this will be stored in the configuration database. So it's just stored there. When this interface here, the web portal, you say, I want to activate a new configuration. What you do here is you ask this application here to read what is in the database and inform everybody that we have a new configuration to apply. Each of these applications will go get the information related to their module and apply the changes. Then we saw TBrouter here, right? So it has access to the LAN 1 interfaces or the LAN 1 interface for the transcoding network connecting to the hardware. Any information that comes in here will be processed and maybe blocked or sent to our SIP software, which we call TBSIP. So if you look inside, you see TBSIP. If SIP can understand the message and make it work, it's going to send to Engine. Engine has control over these resources, right? Like the stream server for playing and recording. It has control of the hardware. So it controls many things. That's why it's like the central part of the system. And if it's accepted in the engine, then it can go to gateway. That's where we have the routing table, the static routing table, the call detail records, the routing scripts. Everything else is done in gateway. So the only part which you really make a difference is here. The rest is all configuration that you need to do in the web interface. You see the call trace here as information from both the gateway application and the engine. So both of them will gather information, and if it finds it interesting enough, we'll shoot it to the call trace, and it's going to be displayed. So you will see maybe the SDP information of the call. You will see if it's playing a file, if it's recording a file, you'll see it there. We saw the 300 redirects. So if it's 300 that comes here, it's going to be printed in a call trace. So you have here a syslog, which gathers information about all the other applications, and they are being sent to the syslog to have a specific, like more important information log. Okay. You have SNMP module that is running here that you can, it's activated by default, so you can just use it, configure it and use it. System manager used to be important. Now it's less important, but it manages the 1+1 HA. But the function is pretty limited, but still it's running on the system. So these are all the applications that you can see on the system. I did a list here of what they do in general. All right? And this will help you if you are trying to debug something, where you need to look in the system to understand. So we talked about this, right? Gateway. Anything about call routing scripts, that's the log you'll have to look. It's not much chance to find anything else in other logs. If you know you're getting trouble with the TBrouter, let's say you have the scheduling problem, right? So maybe you need to look in the TBrouter log. If it's a problem in an upgrade, then you will look at TBOMAP, so manage all application and system upgrades. Right, so you can look there. So here it just gives you an overview of the real name of the applications and the functions. All right. One plus one redundancy. So we do DB replication. We talked about that. So we have a configuration database running on both servers. The replication is done through these control 0, control 1 interfaces, and also communication between the application to make sure who is primary, who is secondary, and when do you take over, who is master. And one thing is that it's not supported yet on the cloud platforms. So it may come in later, but for now we don't support 1+1 on these cloud platforms. With all the applications you have in the system, some of them are active, some of them are active standby, and some of them are master-slave. For example, the database is running master-slave. So you have one master database in the system and one slave. So everything is done, every configuration is pushed to the master database, and then the slave one is just replicating. If the master one dies, the slave one takes over and becomes master. Active, this means they are always running on both systems, right? And both of them are active. So TBrouter, they're always running on both systems, right? But one of them will be processing the main traffic. Right? Most of the time, it's going to be just one. Right? OAM is active, so it runs on both systems. It will make sure all the applications, each of the systems are to the same version, and they're all running. But you will have a master OAM. So one of the two will be a master and control the whole system at a high level. SNMP is active. So you have it on both systems. So you can do requests to one or the other. It's going to reply. The SNMP will reply from each of the interfaces. And then you have active standby. So these ones, gateway, engine, SIP, call trace, right? They run on one unit, and the other unit, they run as standby. Right? And that's what we're working on for the no loss of call in SIP HA. We call it SIP HA, no loss of call. It's this module here that needs to keep the call when we switch over. So it's going to be active standby, but with checkpointing. Right. So that's what we're working on here. These ones here can resync already, but what we're missing is this one here. Okay. So if you kill gateway, application gateway, it's going to restart and resync everything. Right. Even if you're just on a standalone system, if you kill it, it's going to resync all of it. Same thing for engine. It's going to resync all the system, no problem. Okay. So if you look in the application status list, you can see all the applications that are running. And I noticed when I did this that there was we don't see the TBrouter here. I think it's just because it's not controlled with TBOMAP. It's a special application. But you see here the current state. Right? So here you see, for example, gateway is running on the host A2, and gateway is running on the host A3. So you have two applications, same application running on both systems with the same configuration. And right now it is active on A3, and it's standby on A2. And you get all the information of all these applications. And it doesn't matter where it's running. It's just for you to know. Maybe, so we've been working with a customer to do redundancy tests, right? So when you want to do a redundancy test, the behavior could be different if you're running the unit or the application standby on one or standby on the other, right? So he looks at this and say, okay, everything is on the secondary, and I can reboot the primary, see what happens. Or everything is on the primary, and then I reboot the primary. What happens? It's different behaviors, right? So that's one way to see it. The other way is what we saw yesterday, right? So you can just see here, these are the running applications. Okay, you see the green ones here. The server is the primary, the green one is the primary, and the blue master slave here. Okay. And then green is active. So you can see it this way as well. This is the TBX CLI Tools remote we tried yesterday. Okay, type of protections on the system. One is denial of service attacks. So the goal of these types of attacks is to use all the resource of the target system so that it cannot respond anymore to any other requests. Or prevent access from other users which should be allowed to access it. Okay. Usually a DOS is from a single IP address. Okay, and it's sending huge amounts of data which could be valid or not valid. Sometimes you can crash systems by sending non-valid data. And one of the things that is important here is that it may come from a known device. Okay? So if it's an allowed device, then it's more difficult to block, right? So if it's an unknown source, it's easy to block. But if it's a known source, then it's more difficult. Okay, so we need to identify the behavior of the attack and shut down the traffic from this source. Okay. You have the distributed denial of service attack. Right? So it's similar to the other one, except it comes in from many different source IP addresses, right? Which people are targeting one single destination. We've seen big sites go down because of this, right? Big systems. Okay, so how do we protect against these types of attacks? One is we need to support full rate incoming traffic, right? To inspect each of the packets that are received and validate if they're good or not. Right? We need to quickly identify the ones that are valid and say, what, you're good, and quickly identify the ones that are bad and drop them right away. That's why we do that in TBrouter, right? As close as possible to the network interface so that when we receive the packets, in or out. Okay? Now, these are easy. These are easy to do. The ones that are more difficult are these ones, right? We need to monitor the traffic of the trusted sources. All right? So the ones that we allow to come in, but could be still bad. All right? So what we do, and I'll show you that, we ban it if the traffic rate is too high. The default, if you don't change any of the configuration, it's going to be 5 minutes. So if the received information crosses a certain threshold, we'll block this source for 5 minutes. So for the next 5 minutes, if we receive something from them, we'll drop it right away. After 5 minutes, we'll open it up again and see if it's still in this condition. If it crosses the threshold again, then we'll drop those packets for 5 more minutes.
If we want to, is there a way to unban or we need to
Manually, you mean?
manually unban or?
Let's look at the status for that. Let's look at the status after. Probably you can. Let's see. There are two factors to trigger distributed denial of service. All right. Here I didn't talk about the drop entries, but every time you get one other that is being banned, is put in a drop entry. And then you receive another packet, you drop it because it's in this drop entry list. But maybe we get another source and also it crosses the threshold. So we add another drop entry list. And then we have maybe a long list of drop entry lists. All right. Or our CPU usage, the one TBrouter is using, he finds that the processor is running high. Right? There's two reasons to get into a DDoS mode. Right? So when we get into a DDoS mode, any calls that were already open will remain open. Right? SSH connection, and you will see why SSH connection, this one remains open, so we can still have access to the system and be able to change some parameters. And then you have rules after DDoS protection, they will never be reached. Okay. Everything below that will be dropped. And all rules that happened before will be accepted. Okay, but this is really a serious condition, right? You get too many drop entries. So I don't know what's the list size, but it's pretty big. And you get, your processor usage is just getting stuck processing packets. Okay. I wanted to show you the other, where is it? Ah, it's here, okay. All right. So this is one sample access control rule. You will get these automatically in the system. So you have first your HTTP access to be able to change the configuration, your SSH access, and also SNMP. Right. Then you have your DDoS protection. Then you have each of the NAPs that you will have configured in the system. If you have remote NAT also will be configured here, and the last one is always drop. The first one here is one that we created internally. So that's a manual rule. You see here, manual rule. This is created by the OAM interface. This is created by SIP, and these are there automatically. And here you have links to get to know where these are configured in the system. So you can disable the rules here manually. But this one is already disabled. Yeah, this one is disabled. This one, since it's the manual rule, you can delete it. Okay. So enabled in the order, so you can change the order here. The last one is always drop. So if it doesn't match any of those rules, it's automatically dropped. The automatic rules for the OAM, so that's HTTP, SSH, and SNMP. The automatic rules for the SIP trunks, right, all the NAPs that are configured. Manual rules, so you can add your own rules to the system. And DDoS. Right, so if ever we get into a DDoS mode, then everything else is dropped. It will never get any more packets. Anything that is open now will be open, but the others will be dropped. Just not sure for how long. We can check for how long this is created.
For example, can we move some of our SIP trunks before the DDOS protection, or?
Yeah, you can. Yeah, you can.
More important client will stay up, and
Yep, you can do that.
The registered phone will be down.
Ah, yeah, good idea. Yes, you can do that. However, I think every time you do a new NAP, you'll need to go in the rules and push it up. I don't think you can, while creating the NAP, say, I want to be above DDoS. So you'll need to go every time.
What would be the downside of it?
The downside of?
Putting a NAP before the DDoS.
Well, if the attack comes from that NAP. Right? So it's a good idea to do it this way, because registered phones, well, yeah, maybe somebody can get hacked or they can fake some registered phones and do that. But a carrier that is accepted and you have not much chance they get hacked, then you can leave it. Yeah. So yeah, it's a good idea.
With the DDoS rule in place, once that activates, isn't that basically doing exactly what the DOS attacker would want and shutting down the system pretty well?
Yeah, it blocks, but it doesn't kill the system, right? So calls that are there will remain. Any new calls will not be accepted. And after a while, it's going to reopen it, right? Otherwise, if you really leave a DDoS attack, it's finished. You can't access anything, right? You can't change the configuration, you can't shut it down, you can't do anything. It's completely inaccessible. Right?
So it's there to protect the system so that we can go in and
Yeah.
maybe
Yeah.
create a blacklist for that specific IP or.
Well, yeah, I analyze what's going on for sure. You see what's going on and you know, do something. Try to do something at least. It's not necessarily something that is easy to yeah, exactly. But this, you know, DDoS that doesn't happen very often, I guess. But you know, if you lose all access, then you don't know. Is my system crashed? Is the network down? You have no idea what's going on. Right? At least now you have access. And the calls that are running now should still be running. Right? So.
Is there a trap to see if the SBC is in DDoS?
Yes, yes, there is. Yes, but we should look at what it is exactly. SNMP trap for DDoS. And what was the other question? Was okay, if we can disable an entry, a drop entry. Disable drop entry. You can find that. Special packet types have, I think this is also configurable when you, in the SBC, but by default it's something like this. So maximum 100 ICMP, ARP, or DHCP requests per second. Well, 100 or 50. There's some ARP attacks, there's some ICMP attacks, right? So we take some of it and then drop it. I've seen some of my customers do ping tests for testing performance. And then I tell them, well, no, don't do that because it's going to be dropped and you'll have confusion about performance and protection, right? So, so it's something like that. And ICMP can be disabled in virtual port configuration altogether. So that means nobody can ping your IP. For debugging, it's much easier if ICMP is enabled, but if you have problem with that, you can disable it. The broadcast packets will be dropped. RTP created automatically in the system. And there's a little delay at the end before closing the RTP port, so that the remote side maybe takes a few milliseconds or second before shutting down the RTP port. So we still accept the RTP a little bit of time after the end of the session, so that doesn't create problems in the network. Okay, like destination unreachable ICMPs or something like that. Then it automatically allows hole punching, for example, NTP requests for updating the time of the system. So the firewall the SBC will open it and accept that. Or if we do a ping outside from those LAN 1 interface, going to be accepted as well. So there's a few things like that that will be allowed in the system. So these are the SBC settings, the default ones. And it's a global configuration, right? So you see I said 5 minutes, but here I see 15 minutes. Drop entries, okay? So here 2,000. So that means from 2,000 different IP addresses, I went overboard, all right? So that's a DDoS attack, the default mode. I don't think it will happen very often, but the information is there. Okay, that's inside of 5 minutes. So inside of 5 minutes, 2,000 threshold crossed for 2,000 different IPs. What else here? These are manual rules. So these are default values for manual rules. When you create the manual rules, it's going to use these parameters, but you can change them when you create them. I thought it was 5 minutes here. It shows 15 minutes.
Mine shows 15 too.
15, eh? Okay, so maybe I need to change the presentation. Maybe at the beginning it was 5 minutes, but now it's has been changed to 15 minutes. These are manual rules, so just an example of manual rules. So except from a range of IPs and specific protocols, destination. So this is really accessing from our internal network to the web portal, which has 12358. And you see there's also a packet per second maximum, byte per second maximum. So anything that goes over this threshold will go in a drop. So if you have an app that you need to have maybe 20,000 sessions, maybe you need to change those default parameters. We don't see them here, but it's something like this, right? So maybe these need to be changed.
Where are the packet filters set?
I'm sorry?
The last screen, where is that setting?
Where do you do this? In the manual SBC, ACL, create new rule, right? So it's an ACL.
Oh, it's an ACL.
Yeah, create new rule. Right, so you can put your stuff here. So you can also do a drop, right? If you know some sources are untrusted and you don't want them, you can force them to drop. But normally, they are dropped automatically, so that's not too much of a problem. These are the things you can adjust. So type of protocol, source destination, packet per second, bytes per second. So we saw this, we can change this. What else here? We talked about that, order list. Yes, we talked about that already. So that's the list we saw here. Okay, so the order is important. So you could take this snap SIP B and push it just above the DDoS protection if you know you're never going to have any problem with that particular IP or source. Okay, so in the status, you see all the entries that were created. Right, the ones that are dropped here. Right, so you will see if some packets, if you're on a public network, you may be getting a lot of those packets coming in, right? Which the SBC just drops, but it shows you into the it shows you in the list here. If you are expecting to receive a packet from a specific source and you're not receiving it, well, you can look in this list here and see if it's not blocked, right? So you can search also. There's some source address, like if you know it's coming from this source address, you can look at it here. The reason why you have this is if you take a SIP capture, well, you won't see this because if it doesn't go through this, you'll never see it up there in the SIP. This is done in a TBrouter very low. And even if you take a TBrouter capture, this is done before the TBrouter capture, so you won't even see it here. So one of these entry, you see I don't see anything to, Hugo, I don't see anything to disable the entry or accept it or something. So I don't know if it's possible to see them. So for one entry, you know which IP source and IP and why it was blocked, right? Well, this one was accepted. So threshold, state duration, 30 seconds probably. What else here? Firewall state. DDoS alarm. DDoS alarm. So you can get it in the status. Now we just need to check in SNMP where it is. But you have it here, so if you're there and it's true, then you're in trouble.
Well, at least you know.
Yeah, exactly. Yeah, so you see drop entries count in this snapshot, it was at 147. So we had 147 sources of data that we said it's not good. And we'll only go there if we get to 2000. Okay. Drop entries percent. That's interesting. 7% of the packets we receive are dropped. Okay, almost done. Rules and filters. What do we have here? See here, we can see that's in rules. Okay, firewall rules or SBC rules. How many packets we received. So you can see how close you are to the protection that you have put in the system. How many packets were received or how many bytes were received. So you can see this in the SBC status. Entries, we looked at that already. Entry type. Yeah, so you see here, let's say for example RTP transcoding, that's when we use transcoding. Low delay is when we go directly from inbound to outbound. There is hole punching, so that means 1814 that looks like radius. So radius is open when we can send a radius message. Okay, so these kinds of things here. This is a rule here, right? A specific rule. So we know we received the packet for this SIP NAP.
Can be back.
Sure. All punching. Oui, c'est ça. This one is for rules that are not defined in the system. But since it's initiated from the SBC accepts to send them. So in this example, it is, I think it's a, maybe not, but it could be a radius packet. Okay. So it's something that, well, all punching means it will open for a while and then shut down by itself. Okay. So the other side can send you an answer for a certain period of time. And then I saw you this, I showed you this yesterday, just some information on the usage, but yeah, you have the packet per seconds that are shown here, but that's global to an interface. So yeah. I think the status in the web portal is better than this. Okay. So as you can see, there's nothing for registration specifically, right? So on that NAP, the only thing you can say is, well, if I receive more than this amount of packets or bytes, I will shut it down, right? But we cannot, there's no other tool to analyze what we receive there.
Congratulations, you're making great progress. Time to move on to Module 255 and learn about TB Analytics by clicking in the box over here.